All right, so let me get back into this. Okay, everybody can still see?
Yes,
Yes,
sir.
sir.
Lovely. All right, so the halogenation of benzene. Now, what I was saying before is that benzene has standards. So benzene won't react simply with this. You'll never see, let me change that. Let me just use this, right? You'll never see something like this ever. You'll never see this. This will never happen. As I said, benzene has standards. You need to be much stronger than that. You need to be a little bit better than that, right? So the first step in the bromination of benzene, or the chlorination, or the iodization of benzene, the fluorination, whatever it wants to be, the halogenation of benzene. The first step is the activation of our Lewis acid, step one, right? So the activation of Lewis acid, right? Or what we call our Friedel-Crafts catalyst. I'm gonna be clearing the screen after each step, by the way. And then the last time I go through it, I'll just put everything on the screen without names, right? So we have this. So let's look at bromine in its natural habitat. LOL. So bromine, a regular bromine. So everybody can see this, right? Okay, give me a second. One moment.
Yes, sir.
Let me fix that in the background because mm, no, no, no. All right. So okay, I'm back. Okay, so let's move on. Right, so what just happened? Hmm, okay. Hmm, this doesn't feel right. Okay, so everybody can still see, right?
No, sir.
You can, the screen is gone?
Yeah.
Yes, sir. It's back.
What do you mean? Oh, okay, it's back now. All right, okay, okay. So we can see this now, right? So we have the Friedel Crafts catalyst. In this case, we're gonna be using iron 3 bromide. So we have iron 3 bromide like this, all right? What's going to be happening here? All right, we're gonna have a reaction like this. All right, the electrophile is going to be attracted to the positive iron here. All right, following, following so far.
Yes, sir.
All right. So what we're going to end up with is something that looks like this. So let me actually remove all of that so you can see what the actual thing is gonna be. So let me just redraw it in a really simple way. Bromine. I'm sorry if the drawing doesn't look up to your standards. So it looks like this. All right. What we're gonna end up with is something that looks like this. Fe, Br, Br, Br. So you can see, guys. We're gonna have a
Yes,
slightly
sir.
okay. We're gonna have a slightly negative charge here because of the concentration of bromine around the iron there. We're gonna have a slightly positive charge here, and then we're gonna have a slightly negative charge here. So electrons are being dragged both ways here. So that's why we have a positive charge there, just to give you guys that information. Right? So we have positive charges across the molecule. So we have a full positive charge there, right? And then we have a slight positive charge here. Right? So here now we have what we call an electrophile. It's positive enough now, right? It's strong enough to actually penetrate the benzene ring. All right, so everybody good to step one? If you're good to step one, just drop a one in the chat. Because I'm going to erase the screen to move to step two. So that's what I want to know if everybody understands before I erase everything and just move on to step two. All right, just let me know. All right, let me just check the chat real quick. Okay, somebody has a question. Go ahead. Shanique, you have a question? Okay, so let me check what the question is. Okay, so why are they three bromine on iron instead of two? What do you mean by that? I would believe that is the structure of Fe3Br, right? So Fe3Br, it speaks to the fact that iron is at its third oxidation state. So it would need not one bromine, not two bromine, but three bromines, because bromine is -1. Therefore, we have a stable complex. Does that answer your question? Okay, all right. So we have this now. So let's move on now to step two. All right. So just gonna do that. Step two now, right? Why I'm going through it like this is because all the other reactions are similar to this. Other reactions involving benzene like this is similar to this. All right. If we don't get to finish in time, we'll
So
just finish tomorrow.
screen's off again.
Go ahead.
So your screen is off again.
Meaning it's white.
No, we're not seeing it at all.
Oh boy, what a festive evening I have this evening. All right. So let me see. Why is it not sharing as it's supposed to? You can see it now.
No, sir.
Okay, I'm not sure what's happening. Mm-mm-mm-mm. All right, so I'm gonna share the PowerPoint specifically. It's not sharing. All right, so I noticed that it's not sharing. I'm not sure what the issue is. Honestly, not sure what the issue is. Does anybody have any idea what the issue would be? Let me just.
Sir, what do you present?